This screencast is going to be for determining if a situation is either exponentially related or linearly related using regression. Our first example is Mrs. Vernon bought $1,000 worth of shares from Acme, and the table shows the value of her investment over a period of 10 years. So the first thing we have to do is go into our calculators and push stat, and we're going to enter the data into lists in order to calculate the regression. So I'm going to go ahead and in list 1, I'm going to put the years. And then in list 2, I am going to put how much money she had in the account after those years. Okay, and now what I can do is, certainly I'm going to run regression, but I also want to take a look at what the stat plot of it looks like, or I should say the scatter plot, and see if I can tell, is it going to be exponential or is it going to be linear? So taking a look at my data, these are my x values here in L1, so my data can go from 1 to 10 or something thereabouts. And then in list 2, my minimum should probably be something around 1,000 or 900 because she did start with $1,000 and then go all the way up to about 1,600. So I need to adjust my window to reflect that. So I'll start at, say, -1 and go up to 10, sure, and my scale can be 1. I think I'm actually going to go up to 15 so I can definitely see that dot, or even 12 is fine too. And then sure, I can have -10 with a max, oh no, not -10. How about 900? Something a little bit closer to where our data is. And then 1,600 can be our max, and let's count by 100s. And then I'm going to make a scatter plot, so I want to do second y equals. I want to make sure my first plot is on, so enter, and then definitely click it so it's on. And then I push graph, and I get a very nice plot here, and this looks like it's a straight line. So let's go ahead and run regression and see what we end up with. So to run regression, stat, calc, linear regression is number 4, and I'm going to calculate. So I end up with a rate of change because I have x plus b. So my equation will be 56.35x plus 974 is my starting value, and my R value, now this is what I want to pay attention to, my R value is 0.998, so I'll go ahead and record that data. And then I want to run linear, or not linear, exponential regression. So I come over, stat, calc, and then it's not on the page because it's actually option 0, which is all the way down, and you can either click 0 or scroll down to expreg, and then run exponential regression. And we come up with something, and the R value, oh, check this out, this R value is even closer. So even though our graph looks like a straight line, it is actually a curve. We just can't tell that it is a curve. So we're going to go ahead and record this data. And then we can even think about a sentence that we can write based on the exponential function, since the R value is so much higher, or even not so much higher, but it definitely makes it so that we can say our function is an exponential function. We can talk about how much interest Mrs. Vernon is earning each year, and we look at our common ratio to determine how much interest it is. And then remember to, if you're given a problem that you have the percent that is being earned annually, then you divide by 100 and add 1 to it. So here we have the common ratio, which is 1.045. So we want to go backwards from that and try and determine what our percent is. So we have to subtract 1 to get the decimal form of the percent, and then multiply by 100, and then that gives us the percent. So Mrs. Vernon is earning 4.5% annually. Go ahead and fix that 9. And then if you pick a number, say 25 years from now, you want to know what Mrs. Vernon would be making, then, or not making, how much she would have earned. You would use this equation and you would substitute in 25 for x, because x is the number of years. So you have 999.84 times our common ratio here, 1.045, raised to the 25th, because we're trying to find how much money she'll have after 25 years. And then we push enter, and we learn it's about $3,004.95. So rounded to the nearest dollar, Mrs. Vernon would have $3,005 after 25 years. And so we will just tack that on to the end of our sentence here. I don't necessarily know if I like the word earned, so I think that I'm actually going to have and she will have $3,005 after 25 years. She'll have that much money in her account.